Hello guys, how are you? Once again, welcome back. I'm Professor PM Vibhuti. I'm going to talk about another important topic from operating system topic, which will help you in preparing for NET SET GATE examination. And the topic that I am going to discuss today is known as page replacement algorithm, known as a FIFO. So first thing, FIFO is an oldest policy, and FIFO is one of the most popular policy in page replacement. In fact, it is not that efficient, but still it is widely used. See what FIFO stands for: first in and first out. Means the page arrived first will be replaced first, right? So this is the simple policy that we are adopting for in case of a first in first out. Now see how FIFO work. We will identify the oldest page in a memory, and then we will replace that particular page with the newer one. But here I am going to show you some tricks which will help you in solving an FIFO algorithm. Now see with one example. See, this is a page string, means this is in this sequence we want the pages to be ported in a memory, and this is a page frame size. You can see that page frame size I consider for solving this example is 3. Now see the first page number 7. So we need to apply one simple algorithm of 3 steps. So first step is check whether that particular page is available in memory or not, right? So see, is page number 7 available in memory? Answer to the question is no. If it is no, then check for a second step, that is check if there are any empty slot available. If there is any empty slot available, simply put that particular page in that empty slot. Now you can see I have 3 empty slot available, so I will put that particular page 7 in any one empty slot, that is first slot. Now here I have another page 0. First location is already consumed by the page number 7. Now 0. Check is it available in memory? Answer the question is no. Check any empty slot available? Yes. So put it in an empty slot. So I choose an second empty slot to put 0. Then next I want a page number 1. Again same. Is it available in memory? No. Is empty slot available? Yes. Then put it in that empty slot. So this is how we fill the first 3 pages. Now try to understand these first 3 steps, or first this sequence of step is same for all the algorithms related to page replacement. It might be FIFO, it might be LRU, or it might be algorithm related to optimal page replacement algorithm. These steps are same or identical in all algorithm. Now let's proceed for the the separate part. Now you can see I want a page number 2. Again question is very same. Is page number 2 available in memory? Answer to the question is no, it is not available. Is any empty slot available in memory? No. Now here comes an important thing. In this case we will generate an page fault, and we will call an operating system to replace a page. So what operating system will do? Operating system will call an page replacement algorithm. In our case it is an FIFO. So it will call FIFO algorithm, and it will ask a FIFO algorithm to replace or identify a page to be replaced. Now we have 3 options available over here. Now FIFO will choose the oldest one. Now here the oldest one, or the page which arrived we can say in a history as max as possible old page, that is a page number 7. So we will replace a page number 7 with 2. So this is the traditional method of identifying a pages to be replaced with a new page. But here I am proposing another simple method known as a clock method. Very simple method which I invented. See, this is how a clock works. In case of a clock, we have a numbers written over here in a clock like 0 to 12, and once 12 complete, it goes back to 1 and repeat again. But here in our problem statement there are only 3 page frame. So that's why I will design a clock with the 3 numbers only, 1, 2 and 3. Now initially clock hand it at 1. So it will replace the first page. You can see that this is the first page been replaced, right? It is the first location. Now I want 0. 0 is already there in the memory, so no page fault generated and no page replacement takes place. Now I want 3. Do we have 3 available in memory? No. Do we have any empty slot available in memory? No. Now we will go for our replacement. Now see that clock hand is advanced to the second location, so it will replace the second page. Don't see when that page arrived, how that page arrived, what was the time when that page arrived. Don't think about that. Just replace a page which is at a second location. Now next time we will replace a page at a third location. Now see, we want a page 0 again. Do we have page number 0 available? No. Any empty slot available? No. So replace a page at location 3. So that is 2, 3, 0. This is how we replaced a 0 with a or we can say third page, that is 1 with a 0. Now we want page number 4. Again, is it available in memory? No. Any empty slot available? No. Now see one very important thing happening over here. Now that clock had reached to the maximum location, that is 3. Now it will go back to the initial value 1. So this time without thinking I will replace a page which is at location 1. So this is how I replaced a page at location 1. Now that clock hand will proceed to the second location. Now next page which I want is a 2, which is not available in memory. So I will replace a second page like this. Now you can observe one very simple thing. What happens in FIFO? 1, 2, 3, 1, 2, 3, 1, 2, 3 means continuously that pointer is descending down from 1 to 3, right? So that's why it is something like, if we have page frame size as a 3, so it will be something like this: 1, 2, 3. If I have a page frame size as a 4, then 1, 2, 3, 4. 1, 2, 3, 4, so on, right? Now I want 3, to which one is replaced? 1, 2, 3. Third page we will replace with a new page, right? Now I want 0. Again, third is completed. I will go back to the 1 and I will replace the page at a location number 1. Now you can see that this is how we solve the entire FIFO. Now let's calculate total number of page faults. So total number of page fault is nothing but counting these arrows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of page fault in this particular problem statement using FIFO algorithm is 10. I hope you like my method, that is nothing but clock method, in which the sequence we are going to maintain as a 1, 2, 3, 4, 1, 2, 3, 4, like that. Okay, use it for solving other problems related to FIFO. Till then, best of luck. In next session we will see few more algorithms related to page replacement. Thank you.